Okay, let's look at this question, this part. Okay, you take note there's no weight here. So 4 centimeter is the original length. Okay, so the original length of the spring is 4 cm. Okay, describe the relationship between the loads and the length of the spring. So you should say, as the load increases, the length of the spring also increase. Okay, so this one is described. Okay, next, this one is to complete this table. So when completing this table, you need to take note that this is the part they mentioned extension. Because sometimes instead of extension, they'll put the word length. But in this situation, it's extension. So you notice that if the mass is 0, so this is also 0 because the spring doesn't extend. So when it's 2 kilogram, right, the extension is this one minus this. So 7 minus 4, this is how you get 3. Okay, so if you calculate next one, right? So 13 minus 4, 9. Okay, because the units has been written there, centimeter, so you know to write cm here. So this one is 8 kilogram, right? So 16 minus 4, 12. Okay, notice this is the next number is an odd number. Can you see? Because these are all even number. Okay, so that's why I put here, there's a hint here, calculate carefully, use the mathematical concept of ratio. So that means you can see, you can do the working here. Because 2 kilogram increases, right, by 3 cm. So 1 kilo increases by 3 divided by 2, which is 1.5. So therefore, 11 cm, right, increased by 1.5 times 11. So equals to 16.5. So this blank here is 16.5. Okay, then later you need to calculate one more for the 12 kilogram. Okay, 12, this one. Because when it is 12, right, you see next one, the total length of the spring will be how many centimeters is the 12 kilogram X. So 12, if you use the same ratio, this will get 18. But because they ask you what is the total length, so you cannot put 18. So total length is extension plus original length. So this answer will be 22 cm. Okay, 22 cm. Take note of the units. So cm is, you have to put the centimeters there. Okay, 22 centimeters. Okay, so take note of these questions. This question actually, I designed this and is to test your understanding of how to interpret the graphs. Okay, how to interpret the graphs from here. And then you continue with the next one. This part, there are 2 lines here. Let me enlarge. Okay, can you see here? Okay, in our paper is black and white, so I'll make it bigger. Okay, this is the length of the spring. So number one, you take note, length of the spring, so it cannot start from 0, correct? So can you see the blue color line? The spring Q starts from 8. And the purple one, spring P, starts from 4. So my question is, what can you say about the 2 spring? So we can say the spring Q is longer than spring P. Okay, so what is what's first thing you can say? Q is longer than P. Okay. Secondly, what is our OL? OL means original length. So OL of Q is, see from the graph, is 8 cm. OL of P is 4 cm. Okay, original length. Okay, which is more elastic? Okay, this one is a tricky question. Okay, which is more elastic? Elastic means if you compare for a certain mass, right, how much the spring extend. So I can use one value here to help you to understand. Okay, let me choose a green color. Okay, you find a value easy to, maybe here. Can you see this marking here, this one? I circle here, this one. That's why I'm using this weight, 35. Okay, this part. So if you enlarge bigger, you can see when the mass is 35 gram, okay, the spring P, right? If you see this value is 10, right? Right? You dot across here, okay? You see this is 10, whereas this is 14. Okay, so I want to calculate the extension. Okay, so now I want to see which is more elastic. So you see at 35 gram, what happened? Okay, let me use another color. At 35 gram, so the extension of P equals to, extension means final minus original. Okay, P is 10 minus 4. Okay, equals to 6 cm. Okay, then the other one, extension of Q equals to, okay, 14, right? Minus original is 8. 14 cm minus 8 cm. So what do you notice? It's also 6, right? That means these two springs, they are having the same elasticity. Okay, so both springs are equally elastic. Okay? Both springs are equally elastic. Okay, the other thing which I like to show you is because as long as you notice these two springs, the length of the spring, or sometimes they plot extension versus weight, right? If they are parallel lines, right, it means the elasticity is the same. Oh, you take note of this. So if they are parallel, or if you do the actual calculation, you will notice that they have the same extension. Okay, this one, 6 centimeter and 6 centimeter. So they have the same elasticity, or they are both equally elastic. Okay, let's look at another spring. Okay, now I have a spring A and spring Z. So the same questions. What can you say about the two spring? So which is longer? Can you see at the beginning? This one, right? The blue color one. So spring A is longer. Okay. A is longer than Z. Okay, original length. OL of A. Okay, the reason I ask you original length is I'm training you how to interpret the graphs. So when you see such graph, do not be scared, especially for girls. Because I know some girls, they see this type of graph, they get scared. So now I'm teaching you. So you see original length of A, right? Look at this A, spring A is this line. Can you see 6 centimeter? So you just put 6 cm. So OL of Z is, okay, Z is this one, the red line is 3. Can you see between 2 and 4 is 3? Okay, now they ask you, which is more elastic? Okay, which is more elastic? A very good point to indicate is actually at 30 gram. You can use this value here. Can you see at 30 here? These two springs are actually intersecting. They are having the same, they are both spring at 10 centimeters. So we can answer this question first. At 30 gram, okay, at 30 gram, both springs are extended to 10 centimeters. Okay, then we can also, since we are here already, right? We must well use the values to calculate extension. So at 30 gram, extension of A equals to, okay, A is this one, the blue one you calculate. So it's 10 cm, right? 10 minus what? 10 minus the original one. Okay, A is this one. Original is 6. So this one you will get 4 cm. Okay, then I use another color. Okay, let's see. Now the other one. So at 30 gram, extension of Z equals to Z is a red one. So it's also 10 cm minus the original one, 3 cm, equals to 10 minus 7 is 7 cm. So you will notice that for the same mass, right, spring Z extended more. Okay, spring Z, spring Z extended more than this. So this we can conclude spring Z is more elastic than A. So which is more elastic? Spring Z. Okay. So spring Z, Z is more elastic than A. So this is the conclusion. Z is more elastic than A. So once again, I would send this to you. So just a quick review. If you see graphs, they are parallel, means they are the same elasticity. Calculate original length, because this is the length of spring. So original length is when there's no mass hanging on it. Okay. So this part is calculate original length. Then how to calculate extension? You use a certain mass. Make sure you choose a value that is easy to indicate. Okay. Do not choose those values that are in between the squares. Okay, what do I mean by in between the squares? You see like this value here is not very clear. So if you choose, let's say 60, if you choose 60, this is also not very clear. Can you see? So you choose at the right intersection where the line cuts a certain value. Okay, this is also very clear. You see, if you choose this one, that's mean at this 80 gram, right? Okay, at 80 gram, you go and find out what is extension. Okay, so this is 22, and then this is 18. Okay, so you choose the right spot to calculate the extension. So for two springs, they are not parallel. The steeper slope, right, will indicate there is a more elastic spring. That's mean in this case, spring Z, can you see spring Z, the red line is a steeper line. More elastic. Why is it more elastic? Because for the same mass, right, it extends more. So we calculated at 30 gram, Z extends by 7 centimeters, whereas spring A extends by 4. So Z is more elastic than A. Okay, good. So those who need more help, you can contact me. And today is a new student, so I hope that you can join one academy to secure your victory in PSLE science. Good.